Hey everyone, welcome back. Ready to dive in. Today we're tackling systems programming. I know you're all curious about this one. It's the stuff that takes, like your late night show binges and those awesome digital art projects, from a wish to reality.
Yeah.
Have you ever stopped to think about how your computer actually gets what you want it to do?
Right. Like, how do your instructions actually become actions on the screen?
Exactly. So today we're going to explore the languages that make it all happen.
Cool.
They're like the unsung heroes of the tech world, wouldn't you say?
It's like they're speaking a secret language, one that we get a glimpse of every time we see lines of code.
A secret language. I like that.
Yeah, and what's so fascinating about systems programming is that it's all about bridging this gap between human intention, what we want to do, and what the computer can actually, process and understand.
Okay, so our source material dives right into the nitty-gritty with two terms, syntax and semantics. Can you break those down for us?
Absolutely. So think of syntax as the grammar of a programming language.
Okay.
It's all about getting the structure of a code right, just like arranging, words in a sentence so they actually make sense. Semantics, on the other hand, that's all about the meaning behind those words, the actual instructions that they're giving to the computer.
So if the code was a sentence like, please make me a delicious sandwich, syntax would be making sure the words are all in the right order.
Yeah.
And semantics would be making sure that the computer knows what a sandwich actually is.
That's a great way to put it. And just like with normal language, nailing down that precise meaning can get really, really tricky. Our source gives this great example. Imagine the sentence, they are flying airplanes.
Yep.
Grammatically, it's perfect, right?
Yeah.
But the meaning can totally change depending on who they refers to. Are they pilots? Are they controlling the planes remotely?
That reminds me of that Abbott and Costello who's on first routine. You've got the words but the meaning gets lost in translation, and it's just hilarious chaos.
Exactly. And this is where the semantic gap comes in, that difference between what we mean and what the computer actually understands.
Right.
And our source really emphasizes this point, pointing out just how much harder semantics are to get right than syntax.
Oh, interesting.
It's not enough for the code to be grammatically correct. It needs to perfectly capture your intent. Otherwise, you might end up with a completely different result than you expected.
So it's like trying to order that sandwich, but in a totally different country.
Yeah.
Where they might have a totally different idea of what a sandwich is. You might end up with something totally unexpected.
You got it. And that's what programmers have to deal with constantly. They're essentially trying to bridge that gap between human intention and a language that a computer can understand.
Right.
It's a real challenge, but when it's done well, it's what makes all these amazing technologies possible.
So we've got this semantic gap we need to bridge. So how do programmers even begin to tackle that? It seems like, I don't know, herding cats almost, trying to get humans and computers on the same page.
Yeah, it's definitely a challenge for sure. Our source calls this the specification gap. Figuring out how to take that idea, that human idea, like I need an app to organize my sock drawer, and translate that into something that a programming language can actually work with.
So it's kind of like writing a recipe for a dish you've never even seen before.
Right.
Using ingredients you're not quite sure of.
Exactly. And that's where different programming languages come in, right? Our source talks about problem-oriented languages, which are kind of like specialized kitchen gadgets, great for one specific task,
Okay.
but not so much for others.
So a waffle iron is great for waffles.
Yes.
But I wouldn't use it to make a smoothie.
Precisely. And then you've got, procedure-oriented languages, and these are more like your all-purpose chef's knife. You can use them for a wider range of tasks, but they might take a bit more, skill and practice to really master.
This makes me think about how choosing the right programming language is as crucial as a chef choosing the right tools
Right.
to bring a recipe to life.
Absolutely.
It's fascinating how that one choice can impact the entire, development process.
Absolutely. Choosing the right tool for the job is crucial. And once you've got, your ingredients and your tools, you need someone to actually translate that recipe into something, edible. And that's where compilers and interpreters come in.
Ah, yes. The language translators. I'm ready to dig into that. It's like that's the magic that finally brings the code to life, right?
Right.
Okay, so we've got our programming languages, our metaphorical chef's knives and waffle irons.
Right.
Now we need the translators. Compilers and interpreters. Tell me more about this.
You got it. So compilers and interpreters are key to turning those lines of code into something the computer can actually use.
Okay.
Think of a compiler like a master baker,
Okay.
They take this complex recipe, they triple check all the ingredients, the measurements, and then they bake it into this perfectly finished cake. And that cake is your program, ready to run.
So the compiler does all the work up front. It's like meal prepping, but for the computer.
Exactly. And then you've got interpreters. They're more like those amazing street food vendors, who just whip up a delicious dish right in front of you.
Oh, yeah.
Ingredient by ingredient. They read and execute the code line by line, which makes them really great for on-the-fly adjustments.
So if you need to change something in the moment, an interpreter is the way to go.
Yeah.
It's really fascinating how each approach has its strengths.
It is. And, our source actually breaks down the pros and cons in this really handy table.
Mm-hmm.
Compilers are known for their speed and efficiency. Once that code is compiled, it runs like a well-oiled machine.
Yeah.
They also offer a layer of security because the source code itself isn't actually needed to run the program, which makes it harder to tamper with.
That makes sense. But like that perfectly baked cake, you can't adjust it once it's done, right?
Got it. That's the trade-off. Compilers aren't as flexible for those on-the-fly modifications. If you need that flexibility, an interpreter is the way to go.
Okay.
They're fantastic for debugging, too, because you can see the result of each line of code as it's executed.
So it's a classic trade-off.
Mm-hmm.
Speed versus flexibility. Which reminds me, we talked earlier about that ideal programming language. If you could design a language to, really bridge that semantic gap, what would it look like? Would you go for the speed of a compiler or the flexibility of an interpreter?
That is the question that keeps programmers up at night. It's all about finding that sweet spot, between human intuition and machine understanding.
Right.
And our source points out this ongoing tension between those specialized problem-oriented languages and the more general-purpose ones.
Right.
The ideal language needs to be adaptable.
So kind of like a multi-tool that can tackle any coding challenge you throw at it.
Exactly. Imagine a language where you could say, hey, computer, I need an app that helps me find the perfect cat meme for every occasion.
Uh-huh.
And the language itself would figure out all those technical details.
Wow. That would be incredible. No more getting lost in the weeds of syntax errors.
Yeah.
A dream.
Right. It's a vision that a lot of developers are working towards, especially now with the advancements in artificial intelligence and how computers understand human language.
That's so exciting. It feels like we're on the cusp of a whole new world of possibilities.
Yeah.
We've covered so much ground in this deep dive, from the basics of how programming languages even work, to the challenges of the semantic gap, to the tools that make it all possible. It's given me a whole new appreciation for what's happening behind the scenes. Every time I open an app, browse the web, it's amazing.
Yeah, me too. It's incredible to think about, all the layers of ingenuity that go into making technology so seamless for the users who get to, experience it all.
Well, for you listening, remember, this deep dive, it was curated just for you. So if you're feeling inspired and you want to explore more, there's a whole universe of knowledge waiting to be discovered in the world of systems programming.
Happy coding, everybody.
Until next time.